All right, well, we are in Orlando at the 2023 ARA show, and I am joined by Dan Cook from Southwest JCB. Welcome.
Thanks. Good to see you again and be with you again, Mark.
And obviously, when you start getting into machinery that's more high-powered on certain applications, is there any other innovative areas that you've been working on to try and, bring out the latest technology?
Absolutely. In 2020, JCB globally explored the use of hydrogen fuel cells, and a 200 class excavator was test fit with a hydrogen fuel cell. The machine was entirely reworked to accommodate the new componentry that goes into it. And even though the project consumed a significant amount of time and resources, it really helped JCB understand the application of hydrogen in that type of a use case. Now, if you think about where an excavator gets operated, it's operated in a dirty, dusty, rough, aggressive type of an atmosphere. And a hydrogen fuel cell is very, very sensitive to those types of conditions. And so while the technology worked and the machine was an absolute success from a does it function and do what we ask it to do standpoint, yes. But when you start looking at the practicality of the fuel cell in that application, what it takes to service that machine, whether it's an end user or a dealership service model, the fuel cell just started to show that it's not the most appropriate and suitable application. So one of the things that JCB learned is that with transient load profiles, which would be, if you think about an excavator's scooping and digging cycle, as the operator is extending the digging boom down and into the earth, it's a low load. And as it engages the ground and scoops and lifts the earth, it's a high load. That's a transient load. The hydrogen fuel cell was just not best suited to handle that type of a transient load. And we would see transient loads in all other types of applications that a fuel cell might get fitted into. A telehandler booming up to drop a load of cinder blocks and place it on top of a scaffolding from a no load to a fully loaded condition. That's a transient load. So one of the ways to overcome that is to utilize a battery technology that interfaces with the fuel cell, and the battery would handle that initial surge or inrush of that transient load. But there's no place to put the batteries in an excavator that's also got a hydrogen fuel cell. So the form factor of the host machine starts to inhibit the usefulness of a hydrogen fuel cell. But hydrogen is absolutely a technology that JCB believes in, and as a fuel source, it absolutely has a future. So when you think about the other way to generate energy from hydrogen, you combust it in an internal combustion engine.
So this is a big difference here. So rather than converting, actually building a brand new engine. That's basically what JCB went through. And this is like a first that's occurred in the world, yeah?
Yes, it absolutely is. Very, very proud of the brand that I represent, that they're pioneering this charge to create a need and a use case for hydrogen as a fuel source. Hydrogen conversion has been around for quite a while, converting either a gaseous or a diesel engine, and it's just inherently starting from the wrong point, and so it's fraught with problems, and that's why that engineering hasn't necessarily taken off and become a staple in that internal combustion space. What JCB has done is, over the last, call it 18 months, has started with the principles of an internal combustion engine, and other than the bottom end of a rotating crankshaft with connecting rods, has completely built this engine from the ground up. So things like the valve train, the air train, and the mixer bringing the hydrogen into the engine. Going back to 2020, as the fuel cell technology was determined to not be the best path forward, JCB started to develop from the ground up a hydrogen combustion engine. Different than what's been tried over the years to convert a gaseous or a diesel engine to burn hydrogen, this engine really only shares the bottom end of components and similarities, a rotating crankshaft with connecting rods. Things like the pistons, the valve train, the intake system, the turbo, even the chemistry of the oil that goes into a hydrogen combustion engine, that's all brand new developed technology that JCB has invested a substantial amount of engineering thought, money, man hours, development, research into that engine. And I'm very, very proud to say that as of January of this year, we have produced 50 of these engines, and we've installed them into prototype machines to prove the use case that they are viable and they are efficient and they are something that can gain traction in the market as the hydrogen economy continues to keep up.
That's super exciting, isn't it?
It really is. And so when you look at a telehandler and a backhoe, staples on a construction equipment site, staples in a rental company fleet, staples for equipment owners, even though we've made great progress in the development of the engine to consume the hydrogen, it doesn't do us any good if the use case and the user interface of that machine is so materially different than its diesel counterpart that the operators don't want to use it. So as much time and effort that has gone into developing the engine, the user interface is almost more important, because if the operator feels that the machine is more sluggish and he can't dig the number of cycles, or he can't lift the same amount of weight with the same sensitive placement with a telehandler, it's not going to get adopted. There's even pictures in media of Lord Bamford using the fuel bowser that's been created to fuel these machines, and it's no different than wet nozzling diesel into a diesel tank. Same concept, the same use case, the same steps are taken to bring hydrogen from the fuel bowser into the fuel tank of the hydrogen-fueled machines.
Okay, so what is the next step to actually getting these hydrogen-powered machines to market?
Well, one of the exciting things that's happened very recently is that in the UK, the machines that have now been built as prototypes have been approved for testing in real-world conditions on actual construction job sites. While we've done extensive testing within the JCB engineering departments and kind of had controlled environments where we recognize use cases and user interfaces and how the machine just feels when we operate it, we're now going to be able to seek live, real customer feedback on what works, what doesn't work, how is the machine performing compared to the comparable diesel counterpart. So from there, that will steer the next steps that JCB undertakes with the development of not only the engine, but the use case inside the various machines.
Amazing, love it. Well, Dan, thank you for coming on the Rental Journal podcast again.
Mark, thank you so much for having me. It's wonderful to see you here at ARA in Orlando, and I'm looking forward to seeing what the show has in store for us both.